Good day, everyone. Our research study is entitled Low-Cost Seawater Desalination by Passive Solar Membrane Distillation. I am Oliver Roy Mangusing, the group leader. My members are Harvey Jade Ang, Kirk Angelo Galarita, and Sunny J. Sable. Water is a fundamental need for humans and life in general. When there is water, there is life. Humans use water for various purposes such as drinking, food preparation, bathing, washing, and others. In these various uses, water with a low concentration of dissolved salts is needed. However, only 2.5% of Earth's water has a low concentration of dissolved salts in the form of fresh water. The remaining is saline water in the oceans. This large reservoir of saline water, however, can be tapped using desalination. Desalination is a process that removes minerals and salts from saline water, producing water with a low concentration of dissolved salts. Many desalination methods are possible. One of these is membrane distillation. In membrane distillation, a hydrophobic membrane acts as a barrier against saline water, but allows pure water vapor to pass through. This process is driven by a temperature and vapor pressure difference. The condensed water vapor is then stored for future use. In this study, the membrane distillation is powered by the sun. The sun creates the temperature difference and consequently the vapor pressure driving force. Also, the membrane distillation is passive, which means that it is self-operating and all processes occur without mechanical moving parts. This helps the device keep a low cost because of lower capital and operating cost.
For the research worksheet or the research statement of the book, first we find the topic we are most interested and we made a consensus on the topic of passive seawater desalination, and we are very curious as to how this works, how it is made, and how does it compare to the existing reverse osmosis. So from the many questions that we asked from this topic, we came up with a main research question, which is how do we design the equipment, what components should be used, and how should they be arranged. So from this main research question, we asked 8 specific questions which revolve around on the membrane, on the seawater, on the hydrophilic layer, on the heat sink, on the analysis, on the iterative process, on the stages, and the dimensions and the shape of the component. From these specific questions, we came up with our main working thesis, which is the design of a high-efficiency and low-cost seawater desalination device through passive solar-driven distillation.
The main goal of the team is to be able to design a low-cost, passive, solar-driven membrane seawater desalination device. With this, we need to specify the smaller goals in order to achieve our main objective. And these are to identify low-cost materials and design for the desalination device, to measure the rate of desalinated water production, to measure the salinity of desalinated water produced, to determine the performance of the membrane over time of use.
Other sub-objectives are to compare laboratory performance and real-world performance of the desalination device, to determine the optimum number of stages for maximum desalinated water production. Next, to devise a system for the removal of salt from the membrane. And lastly, to determine the effect of solar intensity on the amount of desalinated water produced.
Here are the testable questions for our research study. First, how much desalinated water can be produced per membrane use cycle? This answers objective number 2. During use, salt will accumulate in the membrane, lowering the rate of desalinated water production over time. Thus, we want to know how much desalinated water is produced before it needs to be replaced because of the very low desalinated water production. Second, how pure is the desalinated water compared to the original seawater sample? This answers objective number 3. It is desired that the produced water has as low salinity as possible compared to the original seawater sample. Having too high salinity may make it unusable for human use.
The third question is, how often must the membrane be replaced or cleaned? So the target objective of this question is the cost and maintenance. So the frequency of the number of times you would replace the membrane would account for the cost, and the cleanup would account for the maintenance. It also tackles the objective and the type of the membrane to be used. The stability of the membrane against some factors would somehow correlate to the frequency of the number of times the membrane should be replaced, and would account for the considerations on the type of the membrane to be used in the experiment. So the fourth question is, in which setting will the desalination device perform better? In the laboratory or in the real world? The target objective of this question is the effectivity of the device as to whether the device would work only in the laboratory or only in the real world, or for both case scenarios. It also tackles the experimental design to be used in the project by asking the question if there is the need to carry out the experiment in the real world, considering a lot of constraints, including as to how to carry out the experiment, the time constraints, the cost, and the limited knowledge we have on the topic.
We also want to know how much salt can the desalination device produce. This does not address any of the objectives, but is still a very important variable to consider. Next, what is the optimum number of stages for seawater desalination? This question addresses the objective that aims to determine the optimum number of stages for maximum desalinated water production for a modular design.
The other testable questions are, how does the solar intensity affect the amount of desalinated water produced? This would address the objective that aimed to determine the effect of solar intensity on the amount of desalinated water produced. And lastly, how much more desalinated water is produced when the membrane is regularly cleaned, compared to when the membrane is not cleaned. This would address the objective that aimed to determine the performance of the membrane over time of use. And that is all. Thank you.